I want to thank Dr. Peter Thomason for inviting me and for all the organizers of CTC for the invitation so that I can speak to you about my passion, my favorite pathogen, nematodes. So today I'm going to be sharing with you a part of my research that deals with presence, incidence, and abundance of plant parasitic nematodes associated with corn in Ohio. So a bit of overview. I'm going to share with you some background. Let's see what's really happening. Then we're going to go to the research approach, and then the meat or the crux of the matter, results in discussion. Then I'm going to finish off with some take-home messages and future work. Now, what are nematodes? So, I'm assuming everyone is thinking SCN, right? Or the soybean cyst nematode. And you are right to be thinking about the soybean cyst nematode because the soybean cyst nematode is the most damaging nematode in Ohio. However, corn, wheat, barley, other agronomic crops, vegetables, even home growers, those plants are also subjected to the depredations of plant parasitic nematodes. So, if I'm to ask a corn grower in Illinois about nematodes, the first nematode that will come to mind is the needle nematode. And we'll figure out shortly why that is the case. In Illinois, Dr. Terry Nebelak also described nematodes associated with corn as the hidden enemy. In Iowa, Dr. Greg Tilka calls them yield nibblers. In Alabama, they're called silent yield thieves. What do we call them here in Ohio? We don't have any name for them. I'm assuming at the end of this talk we may come up with something, right? So that we can have our little coinage for corn nematodes here in Ohio. But what really are nematodes? So they're in the kingdom Animalia. They're in their own phylum, Nematoda. And they're typically unsegmented, microscopic roundworms. And we refer to them as aquatic critters because they need water or they need soil moisture to move. Now, in any given agronomic cultivated field, this is what you will see in terms of trophic groups of nematodes. So this is in order of abundance. So you have the free-living nematodes, the microbivores, or what we refer to as bacterial feeders. Then you have the fungivores, omnivores, predators. Those are the free-living nematodes, or those are the ones that we describe as beneficial nematodes. They're good. But the ones that we are really interested in our research, and anyone, are the plant parasitic nematodes. Why plant parasitic nematodes? What makes them plant parasitic nematodes? So the first thing, plant parasitic nematodes possess what we call a stylet. And you can see that clearly here. It's like a protrusible hypodermic needle. So it goes out and in of the nematode as it feeds. So the nematode uses that stylet to consume plant nutrients and water. And while it is doing that, it can also infect the host plant with a virus, for example. For example, the stubby root nematode is a virus vector, so it can infect the host plant with a virus. And while it is feeding, it is also causing mechanical damage. And ultimately, because of that mechanical damage, it will interfere with nutrient and water uptake. And because the stylet is like a needle, when it pierces the roots, it creates openings for the invasion of other microorganisms such as fungi, bacteria, oomycetes. So you have a big world of problem there with these plant parasitic nematodes. So they are important. But why plant parasitic nematodes in corn? That's why we're all here, right? We want to hear what's happening with corn, not soybean. So I cannot talk to you about corn nematodes, quote unquote, without telling you what the eminent corn nematologist D.C. Norton said. So D.C. Norton said, when present in high numbers, nematodes may cause considerable yield loss in corn. And quite often, these losses may go undetected. And the reason why they go undetected is because the symptoms, the above symptoms of nematodes, they're non-specific. So you see symptoms like wilting, chlorosis, within the field. So you're like, okay, this can be something else. Stunting is also one of the symptoms that you may see, and quite often, or may be attributed to other causes. So when nematode may be a problem, a farmer may say, hey, this is herbicide injury, or this is some other soil dwelling microbe, or this is a nutrient deficiency. But he never thinks it's nematodes that may be responsible for his problem. So nutrient deficiency. If you go into a field and you see purple discoloration, you're going to be thinking phosphorus deficiency. You're never ever going to be thinking the needle nematode. The symptom of the needle nematode, if you have the needle nematode in your field, you will have purple discolorations of the corn plant as well. So which one is it? Needle nematode or phosphorus deficiency? So according to the Society of Nematologists, they estimate that plant parasitic nematodes are responsible for more than $3 billion worth of crop loss annually just in the US. That's mind-blowing. Work done by Conan et al. In 1994, he did some work he did a survey on yield losses as a response to plant parasitic nematodes for various crops in the US. And for corn, he saw as high as 20% yield reduction in the US. That was the highest. And the state that recorded that 20% was Florida. And the nematodes that were responsible for that 20% were the sting and stubby root nematode. In Ohio, in that same paper, he reported that we had 1% yield loss. And that is approximately $11 million. And that was because of the lesion nematode Pratylencus. Now, $11 million yield loss as a result of the lesion nematode in 1994. This is 2019. So, you can imagine that this figure is higher. I'm not going to tell you how much higher, but it is most certainly higher. So our very own Dr. Terry Niblack, she recently said nematodes are probably a much bigger problem for corn growers than we have thought before. For example, in our recent survey, that's some of the work that I'm going to be sharing with you today, we found that about half of the corn fields in Ohio have lesion nematode population densities at or above the threshold for moderate to severe risk of injury. So, as it relates to corn and nematodes, there are more than 60 different species of nematodes parasitizing corn, just in the US. Worldwide, more than 120 different species. Now, the needle nematode, and I just said if a corn grower in Illinois is asked about nematodes, he thinks about the needle nematode. Now, the needle nematode, Longidorus breviannulatus, in a study done, was responsible for spectacular yield losses as much as 75%, just because of that needle nematode. The sting nematode, Belonolimus longicaudatus, in studies done, we saw severe damage to the corn seedling plots. The lesion nematode Pratylencus brachierus, in Nigeria, more than 25% yield reduction. And right here in the US, the lesion nematode Pratylencus penetrans in greenhouse studies showed severe damage to corn And some work did by D.C. Norton in Iowa, he showed that the spiral nematode Helicotylenchus pseudorobustus negatively affected corn yield. Now, this picture here is showing severe damage to the corn roots by the lesion nematode. Now, the lesion nematode is a migratory endoparasitic nematode. So this is how he feeds. He enters the roots through the epidermis and he heads straight towards the cortical region. So he is feeding inside the cortical region, and it feeds from cell to cell. And as it feeds and moves from cell to cell and it migrates throughout the root, it leaves in its wake necrotic lesions, and hence the name lesion nematode. So that is what you're seeing here. What we're seeing here is severe lesion nematode damage to the root. The roots at the bottom here is showing severe damage by the needle nematode. The lower corn roots there, that's moderate damage. The upper one is severe damage. The lower one, you cannot see it, but one of the symptoms of the needle nematode, you see swollen root tips. And also what we're seeing in that root at the bottom there is what we refer to as root pruning. So the nematode prune the roots for us. And above, you're seeing a stubby root appearance. Now the needle nematode is not the only nematode that can have your corn roots looking like this. The sting nematode and the stubby root nematode as well. So by now, I know I've painted a daunting picture about nematodes and corn. You guys are all thinking, what on earth is happening? Is this for real? Is this guy really talking the truth? But let me bring you down back to earth and bring you into perspectives as to exactly what really corn nematodes are or what they're doing. So, corn nematodes comes in lots of different shapes, size, feeding habits, and most importantly, different propensity for corn. So the corn nematologist G.L. Wyndham said parasitism of corn by plant parasitic nematodes ranges from weak to strong. So I'm going to demonstrate this by pitting nematode against nematode. So let's pit the lesion nematode against the spiral nematode. Now the lesion nematode is considered a severe pathogen. And this nematode is one of the most important nematode in corn production in the Midwest. The lesion nematode. So that's a severe pathogen. The spiral nematode is considered a weak to moderate pathogen. So you need anywhere between 301 to 500 spiral nematodes per 100 cc of soil to say, hey, I have a problem. So several studies, one study showed the spiral nematode of particular species, Helicotylenchus digonicus, they needed as much as 10,000 of that nematodes before they started to see yield reduction. And then another species, Helicotylenchus dihysteria, in another study they needed as much as 200. So it's weak to moderate. And the lesion nematode, you need anywhere between 51 to 100 lesion nematode before you say, hey, before you start to see yield suppression. So in terms of feeding behavior, the lesion nematode is a migratory endoparasitic nematode. Like I said earlier, it has a very broad host range. The feeding behavior for spiral nematode, they're migratory semi-endoparasitic nematodes. It means that they feed on the outside of the corn root. The head is partially embedded into the root. So it passes the epidermis, and then it goes into the cortical region barely. And then it keeps moving because it's migratory. So it's feeding from the outside. And that also has a broad host range. Some brief morphometrics. The lesion nematode is anywhere between 0.4 to 0.8 mm in body length. It has a short, robust stylet, anywhere between 14 to 22 micrometers. The spiral nematode, its body length is anywhere between 0.6 to 0.9 mm. The stylet is 22 to 30 microns. And in terms of symptoms, we saw the symptoms for the lesion nematode in the earlier slide. You see numerous discrete dark brown lesions. That's what we just saw on the roots. And once they are present in high numbers in the field, you will see severe stunting, chlorosis, and you can have yield losses near 55% for this nematode. The spiral nematode, on the other hand, you will see on the roots numerous small light to dark brown lesions, and if they're in high numbers, you'll see mild stunting, and you can have as much as 15 to 20% yield loss because of the spiral nematode. Let's pit the stubby root nematode against the stunt nematode, and I promise you this is the last pitting. So the stubby root nematode, so that's considered a moderate to severe pathogen. So you need anywhere between 51 to 100 stubby root nematodes per 100 cc of soil before you begin to see yield reduction in corn. The stunt nematode, on the other hand, it's considered a moderate pathogen at best. You need anywhere between 100 to 200 stunt nematodes per 100 cc of soil before we begin to see yield loss. The stubby root nematode, in terms of its feeding behavior, it's a migratory ectoparasitic nematode, meaning that it feeds on the outside of the root. It has a broad host range, and the stunt nematode is also a migratory ectoparasitic nematode, and that also has a broad host range. Some brief morphometrics. The stubby root nematode is anywhere between 0.4 to 0.9 mm in body length. It has a curved stylet, anywhere between 28 to 58 micrometers, and some brief morphometrics for the stunt, anywhere between 0.5 to 1.4 mm in terms of its body length, and the stylet is anywhere between 15 to 24 micrometers. So symptoms for the stubby root nematode, you see the root system is stunted, and you see a stubby root appearance. We saw that earlier in the slide where I was showing you the needle nematode damaging the root. That's a stubby root appearance. And once they're in high numbers, they can damage the seedlings of the corn, and you can see stunting, chlorosis, and the corn wilts easily. And most certainly you'll have yield reduction. The stunt nematode, you have the stunting of the root system. That's what you see for the stunt, for the roots. And once they're present in high numbers, you most certainly see stunting, chlorosis, and wilting, and obviously yield reduction. Now, if you were to walk into a cornfield like this, what is the first thing you're going to be thinking? You're not going to be thinking, hey, I may be having a nematode problem. No. You're going to be thinking, maybe this is a low-lying area of the field. Maybe we had some waterlogging, so the corn is dead. Or you may be thinking it's some kind of nutrient deficiency. Or you may be thinking whatever. But you are not going to necessarily say that this is as a result of nematode. And this here is actually a field, a cornfield in Nebraska, and we are seeing here severe sting nematode damage. Here is a cornfield in Iowa. This picture was taken by D.C. Norton. And this is a needle nematode. This is the field showing needle nematode damage. It's not that clear, but you can see that the corn is not growing well there. And I don't know where this cornfield is, but we see, if you look closely, you can see patchy growth in relation or as a result of the lesion nematode. Okay, so how did we approach our research? In this case, it's a survey. So what we did? During 2013 and 2014, we took 425 samples, anywhere between growth stages V3 to V6, from 6 soil regions. Now, these were the soil regions, and you can see that the soil regions that we chose, they're more so to the western part of Ohio, and that's where you have most of the corn production. So we took it from 6 soil regions, and from those 6 soil regions, we chose 4 to 5 counties, and which gave us a total of 28 counties. And these are the 28 counties that we sampled from. And from each county, we arbitrarily selected 15 to 16 fields. We also evaluated cropping sequences, continuous corn, corn soybean, and corn soybean wheat rotations. We evaluated 3 tillage type, no tillage, conservation tillage. Conservation tillage here, we placed vertical tillage, reduced tillage, and minimum tillage, and that's what we're referring to as conservation tillage here, and conventional tillage. Soil analysis was also done for soil pH, EC, and PSD, particle size determinations. So we sampled our nematodes in the fields by using a 1-inch soil probe, and we used that to take 20 soil cores in a zigzag manner in the field, and we took samples at a depth of 4 to 5 centimeters, and those cores were pooled together. And then we stored them in our cold room at 4 degrees Celsius until we were ready for processing. Now, nematodes were extracted from 100 cm cube of soil, and the wash and flow extraction method that utilized sieving and decanting was used for nematode extraction. Nematodes were further extracted from the soil mineral fraction using sucrose centrifugation, and they were separated from the root fraction using the Biermann funnel techniques. Nematodes were then identified using the dissecting and compound scope. Okay, so this is the crux of the matter, the meat of the matter. What is the data saying to us? So results. So let's look at plant parasitic nematode complex in cornfields. So I talked to you about trophic groups earlier. So for our survey, this is the overall picture. Total nematodes, period. We saw a little over 50% plant parasitic nematodes in our survey. The rest were free-living nematodes, of which the microbivores or the bacterial feeders were the most. Now, in plant pathology, we don't only look at symptoms, but we look at signs. Signs is an indication of the pathogen, or a part of the pathogen. So I want to show you our signs. In terms of nematology, the signs are the nematodes. You need to see that nematode before you say, hey, this is the culprit. So these are some mock shots of these critters. So you can see here the spiral nematode. That's a spiral nematode. That will be on your right, and on the top left, that's what the lesion nematode looks like. And in the top, on the bottom left, that's the lance nematode. Then you have there the stunned nematode. That's what the dagger nematode looks like, a very long nematode. The pin nematode, that's the smallest of them. And then that's what the stubby root nematode looks like, and the ring nematode. Okay. So what did we find? In terms of field sample, this is absence and presence. So 425 fields were sampled. In those fields, how much, at what frequency or at what incidence we found a given nematode. So you can see Tylenchets there. You see 96% of the samples were positive for Tylenchets. But let's ignore Tylenchets for now, because we are not too sure what the Tylenchets are doing. They're fungal feeders, and in some cases they're both fungal feeders and plant parasites. So let's ignore that for now. So for the spiral nematode, we saw that in 94% of our fields. Lesion, 80% of our fields. The lance and stunned nematode were seen in 48% of our fields. Pin nematode, 57% of our fields we saw pin nematode, and 37% the dagger nematode. Now, the cyst, ring, and stubby root nematodes, they were at lower frequencies, but not because the stubby root nematode was seen in just 30% of our fields. It means that that's a nematode that we should not pay attention to. That's a nematode that we need to pay attention to. So I wanted to do what I call a tri-state comparison. So just like we did a survey here in Ohio, the guys in Iowa and Illinois did a survey as well. And this is what we saw. So all the nematodes that we found in Ohio were seen in Illinois and in Iowa, within Iowa, for the exception of the stubby root nematode and the cyst nematode. And you can see the spiral nematode and the lesion nematode. Those were the most frequent nematodes found in all 3 states. For the needle and the sting nematode, for the needle nematode, we did not find the needle nematode in Ohio. That's good news. In Iowa, 8% of their fields, they had needle nematode. And in Illinois, 2 out of that 587 fields had the needle nematode. Sting nematode wasn't found in Ohio, Iowa, nor Illinois. And the root knot nematode was only found in Illinois. So before I continue with my results, I want to show you what we call risk levels. So these are the risk levels for the 8 morphological groups that we detected here in Ohio. So I want to zoom in to severe risk level. So you remember earlier I was telling you that plant parasitic nematodes range from weak to strong. So you see here for the spiral nematode, you need as much as 301 to 500 before you say you have a problem. For the lesion nematode, 51 to 100. Look at the pin nematode. You need a whole 501 to 1000. So if you are sending a sample to see what you have in your field, you need to place key attention to what are the nematodes you have in your samples. Don't just say, oh, I have so much of this or that. We need to understand what is really happening. So these are the frequencies in abundance and maximum densities for what we found here in Ohio. And we can see for the stunt and the lesion nematode, well, as I previously said, they were found at the highest frequencies below maximum density, meaning that for any given field that we found this nematode, which field had the highest number of spiral nematode or whichsoever nematode. So for the spiral nematode, we had our maximum density for that is 990. Look what is the severe risk level. So it's above. Lesion, 300. Look at the risk level, severe risk level, 51 to 100. It's above. Stunt and lance, 240 for stunt, 106 for lance. Look at the risk levels. They're all above. Then here for the pin nematode, the highest number of pin nematodes we saw was 1,164, which is also above that severe risk level. And the stubby root nematode, this is a nematode that we cannot afford to sleep on. Although we found it in 13% of our samples, the maximum density was 56, which is above that threshold level. Okay, so for the samples that we took, we broke down our nematode population densities in terms of no risk, low risk, and moderate to high risk. And this is what we saw. For spiral, lesion, and lance nematodes, we had almost 50% of our samples at that moderate to high risk level here in Ohio. The pin nematode, 25% of the samples taken had pin nematode levels at that moderate to high severe risk level. Okay, so let's look at abundance of these nematodes by cropping practices and soil region. So what did we see? In terms of cropping practices, so CCC is continuous corn, CSW, that's corn, soybean, wheat, and then CSR, that's just corn and soybean in the field. So for the spiral nematode, we saw higher numbers of the spiral nematode in fields under continuous corn compared to the rotations. But then look at this, the pin nematode. The opposite was true. We saw higher numbers of pin nematodes in the rotation fields compared to continuous corn. And then lesion nematode, our favorite nematode, regardless of cropping sequence, the numbers were the same. So can we use rotation to control the lesion nematode? I may say no. Let's look at tillage. So in terms of tillage practices, we had conventional tillage, like I said earlier, conservation tillage, and no tillage. So the spiral nematodes, the highest number of spiral nematodes were seen in fields under conservation tillage. And like I said earlier, conservation tillage here is a combination of minimum, reduced, and vertical tillage. The pin nematode, highest numbers of that nematode were seen in fields under no-till. And the lesion and stunt nematodes, the highest number of those nematodes were seen in fields under conventional tillage. So in terms of our soil regions, we sampled in 6 soil regions. And for soil regions 1, 2, 3, and 4, that's where we had the highest number of spiral nematodes. In soil region 2, that's where we had the highest number of pin nematodes. Soil region 5, that's where we saw the highest number of ring nematodes. And in soil region 1, we saw the highest number of lesion and stunt nematodes. So this is just a summary of cropping practices in soil regions. So for the cropping practices, the lesion and the lance nematodes, in terms of cropping practices, cropping sequences, they were neither here nor there. The numbers were practically the same. For the pin nematodes, we saw the highest numbers in the rotations. And for tillage, lesion and lance, once again, they were neither here nor there. And for pin, we saw the highest number of pin nematodes in fields under no tillage. And for the soil regions, we saw lesion nematodes in all the soil regions, the highest numbers in soil region 1. And for lance nematodes, they were in all the soil regions for the exception of soil region 1. Okay, so I wanted to share with you guys what we saw in terms of associations of the presence of these plant parasitic nematodes and soil characteristics and cropping practices. So for cropping sequences, we saw that we had significant associations for the spiral, lance, and pin nematode. And for tillage, we saw significant associations for the lance, stunt, and stubby root nematode. And soil regions, for most of them, with the exception of tylenchets and lesions, which had no significance in soil content, tylenchets and stunt had a significant association with nematodes. So for pH, the spiral and lesion nematode had a significant association. In soil EC, tylenchets, lesions had significant associations, but I want to zoom in on tillage and soil pH. So here is what we refer to as odd ratios. Now, odd ratios, in layman terms, is just chances. It's as if you're gambling. What are the chances of me getting heads versus tails? What's the chances of me getting a heart versus a club? So when I say tillage 1 is referred to as conservation tillage, and in this case we lumped no tillage, vertical tillage, minimum tillage, reduced tillage, all those tillages together for conservation tillage, and tillage 2 is conventional tillage. So what did we see? So for the lance and stubby root nematode, the chances of finding a lance or a stubby root nematode in a field under conservational tillage was twice that of finding them in a field under conventional tillage. And the opposite was true for stunt nematode, where the chances of finding a stunt nematode in fields under conventional tillage were twice that of finding them in fields under conservation tillage. Now for the stubby root nematode, this is not a surprise. They are in higher numbers in the no-till field or the fields under conservation tillage because these nematodes are sensitive to soil disturbance and desiccation. So this is not a surprise. So if you have stubby root nematodes in your field, tillage can be used as a management approach. Maybe for lance as well. So the relationships between soil pH and the spiral nematode and the lesion nematode we saw as soil pH increase, spiral nematode numbers increase. And as soil pH increased for the lesion nematode numbers decreased. So a lower pH you'll see higher lesion numbers, lesion nematodes. At a higher pH you'll see higher spiral nematodes. Okay, so some take-home messages and what we're going to do in the future. So obviously plant parasitic nematodes are very common in our cornfields here in Ohio. We found 9 different morphological groups in our fields here in Ohio. We had similar plant parasitic nematodes in Iowa and Illinois. The spiral and lesion nematodes were most commonly found in the 3 states that I spoke about. The needle, sting, and root knot nematodes were not found in Ohio. remember, we only surveyed 28 counties, and that's 28 of the 88 counties that we have here in Ohio. So maybe we need to keep sampling, or maybe someday someone will send a sample and I may say, whoa, here is a needle nematode. A matter of fact, the other day I saw a nematode and it was very close to the needle nematode and I got anxious. I said, whoa, am I seeing the needle nematode for the first time? And then I removed it from the dissecting scope and I placed it under the compound scope. Lo and behold, there wasn't a stylet. It was not the needle nematode. It was just an omnivore, what we call omnivores. So several counties had at least one field with population densities at the severe risk levels for 5 morphological groups. This is very important, guys, and I'm going to read this very slowly. Most corn fields sampled were below the suggested risk level for all plant parasitic nematodes detected. Let's digest that. Considerable variations were seen in terms of presence and abundance of plant parasitic nematodes detected among different cropping systems, tillage practices, and soil regions. We saw variations. So given the observed differences that we saw in terms of the plant parasitic nematode responses to these different factors, no single management strategy will be effective against these nematodes. Obviously, further investigations need to be conducted to ascertain the species of the plant parasitic nematodes that we find here. Species is very important. One species may be problematic, another one is not. More investigation is needed to further ascertain the presence and abundance of nematodes that were not detected in Ohio. Now, I'm not saying that I'm sitting praying to see a needle nematode, but you can never tell. So because of the prevalence of lesion nematode in our survey, in our state, that warrants greater attention because this nematode can be a potential limiting biological factor for corn production in Ohio. We also will be looking at relationships between plant parasitic nematode populations and yield loss. This should be quantified, and this will be, once we have done that, we'll be in a better position to establish Ohio-specific risk levels. So the risk levels that I shared with you, they were taken from Illinois. So as a part of my PhD program, I'm trying to establish Ohio-specific risk levels so we know what's happening here. More specific research needs to be done to evaluate the presence and abundance of various nematodes groups in different cropping practices. And that's about it. So I want to thank my advisors, Dr. Pierce Paul, Dr. Terry Niblack, Dr. Laura Lindsay, Dr. Lawrence Manning, and Dr. Christopher Taylor. I also want to thank the members of the Nematology Lab, members of the Cereal Pathology Lab. Obviously, I want to thank corn growers, the extension educators, of course, and then my funding is coming from OARDC.